Good afternoon. I still remain myself, Alchemist. Welcome to my first edition and my first video in YouTube channel. Today we are going to be explaining pyrimidine synthesis, and I promise you after this class you are going to enjoy this class to the maximum to encounter any problem concerning the synthesis of pyrimidine. Now, what we have here, we have the precursors that we need for the synthesis of our pyrimidine. You need your glutamine, you need your bicarbonate, and 2 molecules of ATP. Here we have our glutamine, which is known to be an amino acid. I think this should not be so new to you. This is what glutamine, which is an amino acid. And here we have a bicarbonate, which has a carbon with a double bond here and also having its lone pair. So this is a bicarbonate with 2 molecules of ATP. Now we have to add up all these molecules, all these precursors, and add them together to have our end product of carbonyl phosphate. But in this process, or in this reaction, we had to add molecule of water to it. We have to add water to it. And what is the name of the enzyme that catalyzes this process? This enzyme is called carbonyl phosphate synthase, and it can be simply called CPS2, and that is the acronym of that phosphate. I think this process should be very easy. It's just going to tell you what exactly you need to synthesize. Definitely we are synthesizing carbonyl phosphate, so it's just enzyme. You always know that your enzyme always ends with the word ACE, carbonyl phosphate synthesis, and CPS2. Now we are having our end product, which is what? The carbonyl phosphate. Now, having this carbonyl phosphate, you can see this structure is mainly derived from our bicarbonate. We all have this side of the bicarbonate. So as I was saying, for us to get the structure of the carbonyl phosphate, can you take a look at the bicarbonate? We have the structure of the carboxyl group. We've gotten the structure of the carboxyl, and what we need in this glutamine is nothing less than the amine group that we have here, and this is it here, this is it here. And the phosphate is derived from what? The 2 phosphate group here, and that's why we're having carbonyl phosphate. And the next thing here we have is to add our aspatate to this carbonyl phosphate, and this is the structure of our aspatate. We have our aspatate to be like this, and after that we have an enzyme that catalyzes this reaction, which is known as what? The aspartate transcarbamylase. What does this enzyme implies? It implies that we are adding an aspartate to what? Our carbonyl phosphate. And the moment we are adding this, we have to remove our phosphate so as we can have our what? Our carbonyl and our aspartate together, and our end product is said to be the carbonyl aspartate. So in the next process, we have dehydrogenase. It is catalyzed by the enzyme called dehydrogenase, and that same process we have to remove the water we added in the initial process we have here. The water we add will also be recycled back out of the system. Now we have to add an enzyme which is called what? Dehydrogenase, for us to get. And what does this dehydrogenase implies? We are removing what? Water from what? From this compound called carbonyl aspartate. And what do we have? And the ultimate result, we have what? Our orotate. This is now our orotate, the structure of the orotate. And in the next product, in the next process or next step, we ought to have a product. We ought to add our PRPP. This structure is called PRPP. That is the phosphate riboxyl pyrophosphate. This is the phosphate riboxyl pyrophosphate. Now, look at this structure. It consists of a ribose sugar, and this ribose sugar has 2 molecules of phosphate, and 2 molecules of phosphate in this structure is called the pyrophosphate. It's called what? The pyrophosphate. So we have to add this structure of PRPP into this reaction of a compound of orotate. So in this action, we need to remove one phosphate from this PRPP, and in the addition of the enzyme, or this process is catalyzed with the help of the enzyme called the orotate phosphate riboxyl transferase. That is, we are putting in, transferring into this reaction our what? Phosphate riboxyl into what? Our orotate. That's the name of, that is what this enzyme implies. Orotate phosphoriboxyl transferase. And guess what? What will be our end product when we add our PRPP into orotate? So what are we going to get? We have to get a compound called uridine monophosphate. A compound called what? Uridine monophosphate, which has a same structure like our what? Our nucleotide. Now we have our, this top is called the orotate side, and this is our what? This is our ribose sugar, and this phosphate here. Now the function of the initial enzyme we added, and you could remember I said we removed a phosphate from here. After removing the phosphate from here, we have to have how many phosphate left from this PRPP? One phosphate. That's why we are having it to be of monophosphate, and we have uridine monophosphate. Can you get that now? We have what? Uridine monophosphate. And on to the next structure, and to the next structure we're gonna get here. We need to chop off this side. We have to chop off this side. Can you tell me what structure do we have here? We have COO minus. So we have to chop off this and remove it from this orotate. We have to remove it from this orotate and change this structure into another kind of nitrogenous base. And what is that nitrogenous base we are going to get? We are going to get uracil. And the removal of this CO2 is known to be what? Decarboxylation. That is, we remove CO2 from this compound. And we have an enzyme that catalyzes this structure, that catalyze this reaction to be what? Uridine phosphate synthase. What are they trying to tell us? That this enzyme is already telling us what we are going to get as our product. Uridine monophosphate is already set to be synthesized with the help of this enzyme and this byproduct. And by removing the what? The carboxylic group from this uridine monophosphate. Immediately we chop off this, we are going to get our what? Uridine monophosphate.